This is going to be a quick review of everything that we've learned so far from chapter 3, which was about ER diagrams. So first we learned about entities. So entities are real world objects that you represent using a rectangular box. Then we learned about attributes. So attributes are properties that further describe an entity and you represent them using an oval. So attributes could further be broken down into simple, which means these attributes can take just one value or an atomic value. So an example could be, suppose, the salary of an employee. Then we also saw that attributes could be composite. So composite attributes are those that could further be broken down into components like this. So for the case of, suppose, imagine degree, you could have college, year, and basically type, for example. Then we also learned that attributes could further be multi-valued. So multi-valued attributes are those that could take more than just one value, unlike simple attributes. So an example of a multi-valued attribute could be something like a location of a department, right? And you represent multi-valued attributes using double ovals. So another type of attribute that we learned about was key attributes. So key attributes are those that are always unique. So for the case of an employee, a key attribute could be SSN, and you always underline key attributes. Also, composite attributes could be key attributes as well. So an example could be license plate number, as license plate number is unique for every car and it can further be broken down into number and state. So this was about attributes. Now a new type of attribute that I'm going to talk about is called derived attribute. So derived attributes are those whose value you can derive from pre-existing values. So for instance, suppose you have an employee entity, and this employee entity has a attribute called birth date, right? So you can derive his age. You can derive his age. So you denote or represent derived attribute using dotted ovals. So this is an example of a derived attribute. Now an important thing to note here is that for derived attributes, their values are dynamic. Dynamic in the sense that the age of an employee won't stay constant. It will change as time changes. So that was derived attribute. Okay, so now let's talk about relationships. So we learned that we could represent a relationship, which is basically an association between entities, using a diamond shaped box like this. So we also learned that relationship can have constraints, right? So the two types of constraints are, one, which is the cardinality constraint. It states whether your relation is, suppose, 1:1, 1:n, or n:1, or m:1. So basically for the case of a 1:1 relationship, you could have something like, suppose, an employee and a department, where suppose an employee manages a department. So a single employee will manage a single department, right? So that was about 1:1 relationships. Then we also learned about 1:n relationships, where in the case of where the same example could be applied, say you have an employee and a department, but here an employee works for a department. So a multiple employees will work for a single department. So that was a 1:n relationship or n:1 relationship. Then we also learned about m:n relationships, where you can have multiple participants on both sides of your relationship. So suppose in the case of project where one employee could work on more than one project, at the same time one project could harbor more than one employee. So this was about m:n relationships. And that is basically what cardinality is. Okay, so next we learned about what was known as the participation constraint. So participation constraint denotes whether your participation, whether an entity's participation in a relationship is optional or mandatory. So for example, in the case of this relationship here, an employee may or may not manage a department. It is not necessary that every employee will manage a department. Therefore, we have a single line here. Whereas in the case of department, every department must have a manager, right? So department's participation in this relationship is mandatory, since you cannot have a department without a manager, but you can have an employee who is not a manager. So with single line we denote what is called optional participation, and with double line we denote that participation is mandatory, right? So similarly, at the same time, an employee cannot exist without being a part of a department. So here you have mandatory participation. At the same time, you cannot have a department which does not have any employees. So again you have a double line here. So a similar case follows in the employee project relationship as well. So this was about constraints. So we also learned about a special type of relationship which is called a recursive relationship. So what happens in a recursive relationship is that you have the same entity participating in a relationship more than once. So let's say I have an employee here, and an employee can supervise other employees as well, right? So in a recursive relationship, it is important to remember that you must specify the role which an entity plays. So in the case of employee, you have one employee playing the role of a supervisor and another employee playing the role of a supervisee. In other words, you have one employee playing the role of a boss and the other employee who acts as a worker or a subordinate. So by specifying who's who, you also can clearly specify cardinality constraints. So for instance, one employee can supervise multiple subordinates or workers. So that was a recursive relationship. Then we also learned about a special type of entity which was called a weak entity. So for weak entity, you must represent them using double rectangles like this. For instance, an example of a weak entity could have been dependent. So dependents are those who were dependent upon specific employees, right? And a weak entity must always participate in an identifying relationship with an owner entity. So for the case of identifying relationship, you must also represent them using a double diamond shaped box. So weak entity must participate in a identifying relationship with an owner entity. Since it must participate, therefore we have this double line here because participation is mandatory. So let me write this down for you, that a weak entity must participate in a identifying relationship which is mandatory. And it must have an owner entity. So for example, in our case, the owner entity or identifying entity was employee. So the special criteria about weak entity is that you cannot identify them solely on their own. So weak entities do not have key attributes. They have what is called a partial key. So how do you represent a partial key? Instead of underlining the attributes, suppose if it was name, you use dotted lines to denote a partial key. So weak entities are identified by using a combination of the owner's primary key attribute and the weak entity's partial key. So for here in our example, a combination of its identifying real entities SSN and its own partial key name was used to identify the weak entity. So furthermore, we also learned that relationships could have attributes. So this typically occurs when you have an M:n relationship, right? So suppose in the case of employee who works on a project, you had an M:n relationship here. Now, as I explained in the last lecture, that you cannot have a M:n relationship where, and you cannot have a scenario where you have a specific attribute that's reliant on both the participating entities and place them on one of those entities. You must have that specific attribute on the relationship. So for example, in the case of hours worked, this was placed on the relationship. So I explained clearly why you placing this attribute on employee side would not work. Similarly, if you placed it on the project side, it would not work either. So this was about attributes in relationships.